If you thought black holes were the most extreme objects in the universe, think again, because today we're exploring something just as terrifying, just as fascinating, and in some ways, even more extreme: neutron stars.
Before we begin, if you're fascinated by space, the universe, and the most mind-bending realities it has to offer, make sure you subscribe, follow, and stick around, because every video we go deeper into the cosmos, and it only gets more incredible from here. Now imagine this: a star, far more massive than our sun, reaches the end of its life.
It explodes in a violent supernova, blasting its outer layers into space. But the core doesn't disappear. Instead, it collapses and collapses and collapses. Gravity crushes it so violently that atoms themselves are destroyed. Electrons and protons are forced together, merging into neutrons. What remains is a neutron star. An object so dense that a single teaspoon of its material would weigh about 1 billion tons on Earth. Let that sink in. 1 billion tons in something you could hold in your hand. Now, let's take this further. What if you didn't just observe a neutron star? What if you fell into one? At first, from a distance, it might not look like much. Neutron stars are incredibly small compared to normal stars. Most are only about 20 kilometers across. That's smaller than some cities, but don't let the size fool you. That tiny sphere contains more mass than our sun, which means its gravity is absolutely overwhelming. As you begin to approach, something strange happens. You start to accelerate, faster and faster and faster. Even if you tried to turn back, it would already be too late. The gravitational pull of a neutron star is so strong that once you're close enough, escape becomes nearly impossible. Your speed increases dramatically. Within seconds, you're moving at a significant fraction of the speed of light. But that's not even the worst part. As you get closer, you begin to feel tidal forces. Just like with black holes, but compressed into a much smaller space. Your feet, being closer to the neutron star, are pulled more strongly than your head. Your body begins to stretch, pulled apart, atom by atom. This process is often called spaghettification. But here's the difference. With a black hole, this stretching can happen gradually. With a neutron star, it happens violently and incredibly fast. Within milliseconds, your body would be torn apart. Not injured, not damaged, completely destroyed. But let's say, somehow, you could survive this stage. Let's imagine you had some kind of indestructible suit, something that could withstand the unimaginable forces. What would happen next? You keep falling, closer, closer, and then you reach the surface. Except calling it a surface is misleading, because a neutron star doesn't have a surface like Earth. It's more like an ultra-dense crust made of tightly packed neutrons. When you make contact, the impact would be catastrophic. Even if you were moving at just a fraction of light speed, the energy released would be greater than nuclear explosions. You wouldn't bounce. You wouldn't sink like in water. You would hit something harder than anything you've ever experienced. In fact, neutron star crust
is believed to be the strongest material in the universe.
Stronger than steel, stronger than anything we can create. And beneath that crust, things become even more bizarre. Because inside a neutron star, matter exists in forms we don't fully understand. It's possible that neutrons themselves begin to break down, forming exotic particles.
Some scientists believe there may be a quark-gluon plasma, where particles exist in a free state. Others think there could be strange matter, a completely different form of matter altogether. In other words, the deeper you go, the less familiar reality becomes. Now, let's talk about gravity again. If you were standing on the surface of a neutron star, one of the most extreme things you'd notice is your weight. The gravity there is about 100 billion times stronger than Earth's. If you weigh 70 kilograms on Earth, you would effectively weigh trillions of kilograms there. You wouldn't be crushed slowly. You would be flattened instantly, compressed into a layer thinner than a sheet of paper. Now, here's where things get even more interesting. Neutron stars don't just have strong gravity, they also have incredibly powerful magnetic fields. Some neutron stars, called magnetars, have magnetic fields trillions of times stronger than Earth's. These fields are so powerful, they can distort atoms themselves. If you got anywhere near one, your body wouldn't just be pulled apart by gravity, it would be ripped apart at the atomic level by magnetism. Even from thousands of kilometers away, the magnetic field alone could be lethal. It could disrupt the electrical signals in your brain. It could tear apart molecules. It could literally erase you before you even got close. And yet, neutron stars aren't just destructive. They're also incredibly important to the universe, because when neutron stars collide, the results are extraordinary. Two neutron stars spiraling into each other release massive amounts of energy. Gravitational waves ripple through space-time. And in that collision, heavy elements are formed: gold, platinum, uranium. Many of the elements we value on Earth were likely created in these violent cosmic events, which means the atoms in your body, the materials in your phone, even the gold in jewelry may have been forged in the collision of neutron stars billions of years ago. So, in a strange way, these terrifying objects are also creators. They help build the universe. Now, let's return to you, falling closer and closer to a neutron star. Even before you reach it, radiation becomes a major problem. Neutron stars emit intense radiation, especially in the form of X-rays and gamma rays. This radiation would destroy your cells almost instantly. Your DNA would be shredded. Your body wouldn't just be physically destroyed, it would be erased at the biological level. And then there's rotation. Many neutron stars spin incredibly fast. Some rotate hundreds of times per second. Imagine something the size of a city, spinning faster than a kitchen blender. If you approached one of these pulsars, you wouldn't just fall straight down. You'd be caught in a chaotic, high-speed environment where space itself feels unstable. Jets of radiation would sweep past you like cosmic lighthouse beams, each pass delivering lethal energy. Now let's consider one final possibility. What if,
instead of being destroyed instantly, you could somehow observe everything happening around you. What would you see? Time itself would appear distorted. Because of the intense gravity, time near the neutron star slows down compared to far away. To an outside observer, your fall might seem to slow, but to you, everything feels normal until the very end. Light would bend around the neutron star. The sky would warp. Stars behind it would appear distorted, stretched, and curved. The universe itself would look broken. And then, in an instant, everything ends. No survival, no escape, no second chances. Neutron stars are among the most extreme objects in existence. Not quite black holes, but close enough to show us just how far physics can go. They are the edge of what we understand. A place where matter, energy, space, and time all behave in ways that challenge our understanding of reality. And yet, they exist all across the universe. Silent, dense, waiting. So next time you look up at the night sky, remember, somewhere out there are objects so powerful that if you got too close, you wouldn't just die, you would cease to exist in any meaningful way. And that is the reality of neutron stars. If you enjoyed this journey into one of the most extreme phenomena in the universe, make sure to subscribe, like, and leave a comment. And in the next video, we're going even further. What would happen if two black holes collided right in front of you? What would you see? What would you experience? And could you survive, even for a moment? Subscribe so you don't miss it, because out here in the universe, things are only getting more extreme.